Right, so I'll pick up now with part two of networking. Again, let me get a share screen going. So in the last one, we looked at the simple network um, based on the now defunct tutorial that's gone. But another really nice tutorial, this was a live training that Unity provided called Merry Fragments 2.0. I guess there was a 1.0 and apparently now there's a 3.0. And in this live training, we were rather leisurely walked through the process of setting up two characters, two FPSs in complete detail. The Unity live training has disappeared, but I did find a YouTube of the same thing here for Merry Fragments 2.0, and there's an updated 3.0 version here. And this is Unity Network Manual in the sample games. So again, I won't go through all the details of it, but what I will address is a major flaw that that was in the Mike's final game, which was that you couldn't see the adversary's muzzle flash or the impact site particle effects. And in his setup, he had two particle effects. One, as I mentioned, the muzzle flash, and two, the impact where the bullet hits. And he handled them quite differently. The muzzle flash was a permanent part of the character, a particle effect prefab that was attached basically to the end of the gun. And the impact he instantiated wherever the character was. And then as he needed it, he manipulated its position and started and stopped the particle effect that went with the impact. Each of these particle effects were initially turned off. That's the play on awake was not checked in the particle system, and they're triggered with play and stop. I followed the same structure of commands and remote procedure calls that he used with his kill and respawn of the character. And here's how all that worked. So in the gun script, the gun script is throwing a ray cast to see what it's going to hit. And when the ray cast hits something, whose tag is a player, it issues a command function hit player with the game object that the ray cast has hit. The command hit player that runs on the server itself calls an RPC, resolve hit, RPC resolve hit, that resides on the hit object, on the player that has just been hit by the bullet. So it's catching as its argument the game object that was hit, and it's calling, it's getting the network character script off that hit player, and calling the RPC resolve hit function on that player. Again, with a directive for client RPC, and again with a test to see if we're the local player. If we are the local player, then we can respawn. Our character dies immediately. We can respawn at one of these singletons that we get from our spawn position network manager, and I'm going to turn the character off, turn the renderer off, and I'm going to turn the controls off, and then I'm going to invoke a respawn function after 2 seconds. So what the toggle renderer and toggle controls do is toggle renderer turns off being able to see it, and toggle controls turns off the camera and the ability to move the character around. Toggle renderer again catches the Boolean here, the true, the false, and it goes through all of the different renderers and sets them to false if that argument is false, and the toggle controls takes the Boolean is alive, disables the controller, the script that's running it, and it also turns off the camera, which it does by reversing the bitwise culling mask that the camera, so the camera can't see anything. Well, it could see stuff that it couldn't see before. Respawn, which is this function that's invoked after 2 seconds, just turns things back on. It turns the renderers back on. And if we're the local player, it turns the controls back on with that toggle renderer and toggle controls. Okay, so how I'm going to apply this to the muzzle flash and the impact particles. One thing I wanted to do was make the impact part of the character's prefab rather than instantiating it. That's the way the muzzle flash was set up. It was a game object particle effect that was on the muzzle, and we turned it on and off. And we're going to do the same thing with the impact, except in addition to turning it on and off, we're going to move it around. So let's look at the muzzle flash first. In the gun script, the gun fires when the jump button is pressed. So in the gun script, we press the jump button, and this runs a command function muzzle flash that carries with it the game object that pressed the jump button. And I'm stopping the muzzle flash before I play it so that I'm not playing it twice. Now, the command muzzle flash, which again is running on the server, received as object the game object that called it, the gun, and from that object we're going to get the network gun script, I'll call it NG, and on that network gun script I'm going to call a remote procedure call resolve flash with that game object that had the network gun. Now, the RPC resolve flash that's executing on all the clients, having received the shooter's game object and testing to see that we're not the local player. If we're not the local player, it goes through and gets all the particle systems in all the children, and if the particle system's name matches muzzle flash, it then plays that particle effect. So get all components in the children, all the particle systems, go through them, find the one that's named muzzle flash, and stop and start it. So now we can look at the impact particle effect, and we can handle it exactly the same way, since it's an object that's part of our player. So where we did the raycast and hit something, we can add now a command impact that has as argument the game object that fired the bullet. And in this case, we're now also including the point that we hit, the hit point that was returned by the raycast. I wanted the impact to have some delay so that it didn't occur exactly at the time of the muzzle flash. This reflects the time it takes for the bullets to fly. So I calculate the distance, I know my bullet speed, and I can invoke a splat function after some delay that is a measure of the time distance there. Splat just takes the, calls a command function impact that takes the game object that fired the bullet and the impact effect transform position. That's the object that was hit. So the impact function, which caught the game object in the position where we want this impact to manifest, again, is going to find the network gun of the object that fired the bullet. It's going to call the RPC impact, passing it that game object and the position. And the position, you remember, is the hit point, and RPC resolve impact that catches where the flash is going to be, where it catches the flash and where it's going to be, tests to see if we're the local player. If we're not the local player, then we find the impact particle system, again by searching through all of the particle systems in our children. I put the particle at the position of the flash, and I play it. And you remember, this is called after a delay that's with the invoked splat delay that calls command impact, that calls RPC resolve impact, that puts the particle where it is and turns on the particle effect. Back some time ago, when in Unity 5, this had all kinds of problems. The builds crashed unless they were development builds. It mysteriously fixed itself when I upgraded to Unity 5.4. It seems to work fine in Unity 2.18 and 19. I haven't tried it in 20. Another error that seems to have gone away was something in the higher level API, channel count error local 5 remote 3. I didn't know what this was, but looking for it, I found lots of people who had the same error, and it too went away when I upgraded to 5.4. So these are the kind of things that you deal with in Unity. I also wanted to add a physical bullet that flies along the path of the ray cast from the muzzle flash to the impact. This is a little different in that from the way the two particle effects are handled, because in this case I am instantiating an object. And this will be kind of the way we did back in the simple networking one. In the place where I press the jump button and handle the muzzle flash and all of its stuff, handle the impact and all of its stuff, I'm going to also invoke a command shoot that takes the position and rotation and direction of my parent object, the gun. Command shoot has position, rotation, and direction that the bullet's going to be fired. Running on the commander on the server, I instantiate a bullet, which is similar to what we did in the networking part 1. I give it a velocity in the bullet with bullet speed, and I spawn the object with a network server spawn, and this makes bullets on all of the different clients. So let me show you that in action here. Again, I'm going to command B, which is command B, which is the build and run. So it's building in the game, and it'll start an instance of it here in a second. So here's an instance of it. Oh, I made it too big. Just to show you that I can, I'm going to start it over here on the compiled version. And then I'll go over here and start as the client. And now on the client, I can turn around here, and there's my adversary. I go back to this one, and I turn around here and point at the other guy, and I can shoot him. And blanks out, and the spawn point was right where I was standing, so he came into existence right under me. I've made the bullet really kind of slow so that I can see it kind of pass in front of me here, and if I hit the character, he's gone. Notice the camera couldn't see anything there. Now I'm back over here again, and now I'll shoot the other guy, and he'll disappear and respawn someplace. So very cool and all very neat. Now there's one other aspect, the concept of a lobby. This is a fancier version of this thing here, this network manager that does the connection between the different things. A lobby replaces that. It used to be on the asset store. There was a basic lobby, network lobby. It had the various prefabs and scripts necessary, and there was a worked example, Network Meteoroid, that was a fully functional example of a network game with a lobby. And yet again, Unity has decided to do away with stuff. Happily, I have copies that I placed on my Google Drive at this link, so you can go get that at that point. So we replaced the network manager that was how we started and stopped the game and connected with the lobby manager, which serves the same function. It just does it in a little fancier way. We need two scenes specified in the build settings with a lobby scene that will be scene number 0, and then any game scene as the second or third that we play. The game scene should not have any players, nor will it have a network manager, because the lobby manager, which is a don't destroy on load object, will be carried there. And in the game scene, we can have spawn points where the character will spawn. We need a lobby hook script that lets us customize various features of our characters as they come in. For example, assigning a color or some other attribute. Have a look in Meteoroid to see this. So the lobby hook, which is a lobby hook class, overrides the on lobby server scene loaded for player function. And here it gets the lobby player, gets the player's player component, and sets the player's color. So of course, it requires that the player script have an exposed variable color that will be a sync var, so that it's synchronized across all instances. In start, the character sets its own color. In this case, just finding the cube that shows our character and setting its renderer to be that color. This only scratches the surface of the details of network games. There are a number of tutorials. Many of them are out of date. There's a really gorgeous one for the new system beta, but it's a 36 gigabyte download to download it, so don't do it at home. But let me show you a networked game here, our network lobby game. So again, I have to build this, so I'll build it. I'll build it. And this is, again, compiling it. I'll run it windowed small. And so here are the two games. They're both running here. I'm going to, I'll talk about the matchmaker maybe in a minute here, but I'm going to do manual connections. So here I'll do the host here. So this is the host, and now it's waiting for players. One of the things with a lobby is you can specify how many players have to be in the game. And so here I'm going to join the game. Now that enough players have joined, I can, this player's ready. This player is ready, and the match counts down to a start. And here are my two characters. Over in this game on the green cube, I can shoot the other character. Over in this one, I'm in the red cube, and I can shoot the character here. I haven't bothered with health or anything that kills things, and they can move around. So depending which instance I'm in, they move around. So I'll stop that, and the matchmaker, you saw the matchmaker there. This is a service provided by Unity to host the game for you. If you use the matchmaker, the server runs on their hardware, their server farm. This alleviates some of the local machine hiccups that involve needing to know IP addresses and firewall settings and other things like that. Unfortunately, it's along with this whole UNet is soon to be deprecated, I think 2022, so don't count on it. To access the matchmaker, you have to have a developer account on Unity, and you have to enable multiplayer in the services window. As I can tell, you get 200 concurrent users with a standard account. More than that, you have to pay the money. Here's what my dashboard looks like when I'm running that network game with 2 players. I've got 2 concurrent users out of a possible 200. That's all I know about it. I haven't gone any further than this. All that said, you should definitely have a look at the Unity blog post that describes changes to come. There's also a frequently asked questions that has timelines for deprecation and so forth, so you know how long this is going to last. It will be supported for a while, but it's not the way things are going to be in the future. And from what I've read in this blog post, it's going to get a lot harder. So I'll stop sharing here, and I'll end the recording and see you all in class. So bye.